Hello, my name is Julietta Maffeo, and my project is a pedagogical approach to Arduino learning with an Arduino kit and guide. It is important to note that this is the preliminary steps to the final project as it will not be finished until the end of next year. It is also important to note that while I did start this last semester, I lost the majority of my research about a month ago. However, I do hope that you enjoy what I have so far to offer.
This project is advised by Mr. and Mrs. Dr. Wilburn as well as Dr. Bora. My HAB member is Dr. Hetler and my librarian is Loring Prest.
There are four main types of learning: high-tech, teacher-centered, high-tech, student-centered, low-tech, teacher-centered, and low-tech, student-centered. As high-tech and low-tech are pretty self-explanable, I'm going to focus on the differences between student and teacher-centered learning. Teacher-centered learning is where the teacher acts as the main authority figure. Students are seen as empty vessels who receive information from the instructor through lectures and direct instruction. The student is often graded through scored tests and assignments. Student-centered learning is where the teacher is still an authority figure, but the student is also active in the learning process. The teacher is more like a coach where they provide comprehensive learning material to the student, and these materials are often judged in an informal way, such as group projects, student portfolios, and participation in learning. I plan to use inquiry-based learning as my pedagogical approach. Inquiry-based learning is a high-tech, student-centered learning approach that focuses on investigation and hands-on projects. In this specific model, the teacher acts as a supportive figure that guides and supports the student throughout the learning process. This will complement learning Arduino and coding as they are hands-on skills. Student investigation will allow students to come to conclusions and solutions to problems on their own. Lessons can be designed so that examples which provide the basics and understanding of programs and their framework will be given. As Arduino combines software and hardware, using a learning structure with hands-on approaches will benefit the students. Understanding circuits and Arduino schematics, correct wiring techniques, and input-output applications are a crucial part of learning how to use Arduino. Another key benefit of this learning structure is that it requires minimal teacher interaction. With this approach, lessons can be prepared that supply the necessary background information and pre-worked examples. This loosely guided approach will lead to boosted creativity as well as unique solutions to a variety of problems that could be presented. Inquiry-based learning is effective. Several studies and meta-analyses have been conducted which support this theory. One meta-analysis by Alfieri et al. Supports that inquiry-based learning is effective when compared to the traditional learning method. They offer a mean effect size of d equals 0.3, which shows significance. Another meta-analysis by Furtak et al. Further supports this theory with their mean effect size of d equals 0.5, showing even more significance. Other studies mention that inquiry-based learning plays an important role in the student participation and the learner's responsibility when discovering new knowledge. The European Commission stated that it was a vital component in building a scientifically literate community. As the approach towards Arduino that I will focus on is engineering-based, most of the projects will follow the engineering design process. This complements inquiry-based learning as studies break methods into similar steps. In inquiry-based learning, the student is guided through orientation phase, conceptualization, investigation, discussion, and conclusion. The engineering process follows similar steps: defining a problem, researching it, specifying requirements and wants, brainstorming solutions, developing a prototype, testing the solution, then repeating the necessary steps until a final solution is reached. Both processes are also similar to that of the scientific research process and allow for problem development and iterative creative solutions.
So, what is Arduino? Arduino is an open source electronics platform. This means that any manufacturer can sell an Arduino and that they are a base for many project ideas and problem solutions. These microcontroller boards come in many different shapes and pin layouts. The board shown to the right is an Arduino Mega, which is their largest board currently available. Arduino also uses its own integrated development environment for programming the boards. The programming language used is C-based. These boards allow for analog or digital control of various inputs and outputs, such as sensors and control devices. Kit and other parts will be selected as the base of this project. Before the user starts, they will need to learn the very basics of the Arduino IDE and how to connect the board. The guide will also cover programming basics, basic programming functions, how libraries work, and the basics of electronics. The rest of the guide will be focused on a three-level of difficulty approach. The beginner level will cover basic I/O such as LEDs, push buttons, potentiometers, and other I/O components. It will also cover mathematical functions and the serial monitoring capabilities. The intermediate level will cover components such as LCD screens, stepper brushed and other motors, encoders, and other sensors. The difficult level will cover serial communication protocols such as I2C and SPI, as well as inertial moment units, PID control, path planning, and possibly more. A final project will be open-ended, or the students can follow along with a robot project that will include multiple topics from the various levels, including components such as LEDs, encoders, ultrasonic sensors, and PID control.
Several examples of exercises with a single LED, multiple LEDs, a single multicolored RGB LED, and multicolored RGB LEDs are listed here. A single LED has the potential to simply turn on and off, blink, and fade in and out, also known as breathing. A multicolored LED with red, green, and blue components can display a wide variety of colors, blink those colors individually, fade between each color, and more. It is also important to note that running multiple LEDs at once requires a special coding structure.
An overview of my project. My project advisors are Mr. Dr., Mrs. Dr. Wilburn, and Dr. Fomsey-Bora. My HAB member is Dr. Hetler, and my librarian is Lauren Prest. I plan to use inquiry-based learning to create a guide for the open source platform Arduino. Arduino is a popular microcontroller and IDE with endless possibilities. So long as the user can code and understand the very basics of engineering, any idea could be possible. From hello world to basic LED control to a complex sensor-loaded robot, there are endless possibilities with Arduino. This guide will be for a robotic-centered kit selected/created to understand various levels of software and hardware integration. 3 levels of integration will be included: beginner, intermediate, and difficult. The parts required for the beginner level will be minimal, but as the projects become more complex, the price will increase due to the need for more components. The goal of this project is to make it easier to code and understand Arduino, use Arduino with various sensors, and allow for project production and endless fun and creativity.
Thank you for listening. My references are listed here. If you have any questions, comments, or concerns, please feel free to email me at maf1862@calu.edu as listed below. Again, thank you for listening and have a wonderful day.